Hello, everyone. Hello, everyone. My name is Preeti. I work as a principal machine learning engineer at Wesfarmers OneDigital. And today, I'm here to talk about the machine learning platform that we have built at Wesfarmers OneDigital. So before I begin my talk for today, I just want to take a moment to talk about the company that I work for. So Wesfarmers is one of the leading conglomerates in Australia. As of financial year 2023, Wesfarmers is valued at 43.6 billion Australian dollars. Wesfarmers owns some of the most trusted brands in Australia, like Kmart, Target, Bunnings, Officeworks, and many others. Recently, Wesfarmers formed a new data and digital division called OneDigital, and I work in the data science team at OneDigital. So as you can imagine, the kind of use cases and machine learning problems that we work on are generally around customer preferences, understanding customer journeys, creating customer segments, and so forth. So today, I want to talk about the machine learning platform that we have built at OneDigital. So I'll start with sharing my journey of creating this new platform. Then I'll talk about the platform architecture and how we have built this platform. After that, I'll talk about the migration journey we had of migrating a few workloads in production from the previous platform to the new one. And finally, I'll share a use case of how we have used Ray remote distributed paradigm to make one of our use cases simpler. So beginning with the journey that we had. So back in 2020, we wrote the first version of our platform. This platform was based on Kubernetes, which we self-hosted. We also chose MLflow as the model monitoring and storage solution at that time. For the next 2.5 years, we would use this platform to create our model pipelines and for the day-to-day workbench that the data science would need for their ad hoc experimentation. In the last 2.5 years, what we observed was this platform continued to build a lot of tech debt. So we would face operational inefficiencies in the platform. There would be very long model training and scoring runtimes. We would also face memory issues. And we would face some very specific operational constraint around Kubernetes management. So last year, we decided to uplift our platform. And we wanted to move away from Kubernetes. Being a small team, we had limited resources and limited time to manage the Kubernetes. So we decided to move away from Kubernetes and adopt Ray and Anyscale. At the same time, we replaced MLflow with weights and biases as our model storage solution. So as you can see on the screen, in last June, we made the decision. By July, we had successfully completed proof of concept with the vendors, Ray, Anyscale, and weights and biases. And in September, we kicked off the production build. This March, we released the first version of our platform. And by this May, we had migrated all our production workloads from the previous platform to the new platform. As we had been using this platform for over 3 years, our data science team had a pretty good idea what they wanted out of the new platform. So what we wanted for our data scientists was that they would be able to build, deploy, maintain, and monitor machine learning models in production with minimal engineering efforts. So that was what our vision was. So based on that, we came up with a few guiding principles. So like I said, we wanted to maximize the DS ownership in the new platform. We also did not want to reinvent the wheel. Unlike the last time, this time what we wanted was to have more vendors come in and outsource some of the problematic areas and components of our platform rather than hosting our own services and writing our own software for that. We also wanted to reuse the existing infrastructure. As we were all based on AWS, we wanted to keep the infrastructure as is, but rather do a more of a plug and play kind of approach rather than writing everything from scratch. And lastly, we were a bit risky in our approach in the sense that we wanted to try out the latest state of art technologies that were out there. So we were bold in the choice of the vendor that we made. Now let's talk about the platform architecture and build. So what you see on the screen is our tech stack. So in the EDA and experimentation stage, we have got Anyscale, weights and biases, which are now the new components, along with the previous component like Jupyter Hub and Python, which we use for our data science use cases. Similarly, for our model training, we have been using and integrated now Anyscale and weights and biases. For our CI/CD pipeline, we use GitLab, so our model pipeline is actually written in GitLab. Similarly, for model monitoring and monitoring of the pipelines in general, we used to have Grafana and CloudWatch, so now we have replaced that with Anyscale's version of Grafana. And what we have done is we have integrated Anyscale jobs with Slack, so that's how we have created our alerting mechanism. Our storage and data store is based in Snowflake, and we also use JFrog Artifactory for storing our Docker images and scanning the images. And for compute, we have got EC2 machines, which are now managed completely by Anyscale. Previously, we used to manage it ourselves using self-hosted Kubernetes cluster. Also, we work with our data engineering team, and they use Airflow to run DAGs, which we use to create our data pipelines. And we also use Terraform as our infrastructure as code. So these stars show how we have implemented Anyscale in all those different areas of our tech stack. Similarly, how we have integrated weights and biases also in those different areas of the tech stack. The next thing I want to talk about is how we have implemented our production pipelines using Anyscale jobs. So like I said before, we use GitLab as our CI/CD solution. So what we have done is we have written our GitLab machine learning pipelines. It's there where we create Anyscale production jobs. Now, Anyscale production job, they talk to weights and biases, and they also interact with Snowflake to get in the data and to store, upload, and download the models as well. On the bottom of the screen, what you see is just a code snippet of how our standard machine learning pipeline would look like. So we use the API from both weights and biases and Ray to, let's say, write some Ray remote functions to log into weights and biases and start a Ray cluster. On the right side, what you see is a snippet for a sample job. So this is how we have defined our production jobs. So we've got a project ID. We create our own compute configs. We have our own cluster environment. And then we have got an entry point from which it connects to the Python application code to run a particular Anyscale job. I also want to highlight something else here, which is really helpful for us, is the partnership between Anyscale and weights and biases. As we have integrated both of these separate technology into our platform, it made sense for us to just explore ways in which they work better. So what you see on the screen in this red circle is how Anyscale and weights and biases are working together. So the screen shows the console of Anyscale. So this is a job. From an Anyscale job, you can integrate a weights and biases run. So that's the red circle, will take you directly to a weights and biases run, which I'll show in the next screen. So this is a weights and biases console. And what you see in the circle is a connection from where you can go from a weights and biases run back to an Anyscale job. This is pretty handy for us as we have both these technologies, and at every stage of the pipeline, we use both Anyscale and weights and biases. So the next thing I want to talk about is the production workload and the migration exercise that we did to move our existing workloads from the previous platform to the new one. So just to set some context, in the previous platform where our models were previously running, we had quite a few problems. So our model pipelines would take sometimes too long to finish, either the training or the scoring. As we experience more and more data, as for some of the use cases, which would be on a store level, on a regional level, and sometimes we would work on use cases in which we would work with multiple Wesfarmers division, and we need to combine the data from all the division. We would see the problem of scaling getting more and more. And what that meant for us is we would start experiences models which would not fit in memory of one machine. So either the size of data would get too large, or the size of model itself sometimes would get too large. We also experienced low observability of production models. So in the last version of our platform, what we did was we had Kubernetes. Sometimes we would send some logs from Kubernetes to CloudWatch. But most of the times, what we ended up doing was like literally logging into kube running pod, and would have to SSH into the cluster. We'd have to grab the logs, pull it out. That used to be not so ideal way of looking at logs, of observing the production models. So the debugging was really hard. And lastly, we would experience some very specific inefficiencies around Kubernetes stack. So people who have been used Kubernetes before would know very well that Kubernetes is a fantastic technology, but at the same time, managing a kube cluster is not easy. So as part of migrating to Anyscale and Ray, we had a few focus areas. The first one was code rewrite. So what it meant for us was the code that was already written, and in production, we had to write certain section of the code, specifically the wrappers in the way that the code and the model would interact with the data store. Because previously, we would directly connect kube cluster with the Snowflake. Now, with the new platform, we had to connect Anyscale with Snowflake. So what that meant for us, we had new problems to solve. In the sense, we wrote new API management solution to connect from Anyscale to Snowflake. So we wrote some database utility wrappers, which took us some time. Similarly, as we integrated weights and biases into the new platform, we had to write wrapper around the weights and biases API as well. Another focus area that we had was exploring the improvements. What we wanted to do with the new platform was explore the opportunities of making our models better. So for scalable data loading, we wanted to use Ray dataset. We got the opportunities in one of the models to explore that, and we were quite successful in doing that for one of the use cases. We also successfully implemented LightGBM trainer in one of our use cases. We also played around a bit with RayTune for hyperparameter optimization. Finally, we explored improvements by parallelizing our pipelines by using Ray Remote. As with any new technology, it comes with its own set of challenges. For us, it was a few of the teething pains that we had. Because of the decision that we made that we would migrate the models before we release the first version of that platform, what that meant for us was our data science team would experience very frequent downtimes, so frequent changes in the platform before even the first version was released. So the initial few weeks of this migration exercise had parallel development. So the data science team and the platform team would work really close. At the same time, what that meant for us is we were able to identify issues early on in this platform. That helped us in hardening the platform by the time the platform was released. And with the new set of technologies, we had to work on a completely new coding paradigm. So what that meant for us was taking our data science team through multiple training sessions. So we had regular catch-ups with our Anyscale team and our weights and biases team. And we also had internal knowledge sharing sessions to upskill the team member to use the new platform. Next, I want to share some key results of the migration exercise that we did. So we migrated a few models. So the first model that we migrated, it took us roughly 2 months. The training and tuning time reduction in this first model was around from 2 hours, it got down to 1.5 hours. The data science team experienced improved developer productivity. So previously, the data scientists would just use Jupyter Hub, which was self-hosted on Kubernetes, which was very clunky. Now we were using Jupyter Hub that came out of the box from Anyscale, which was a significant improvement. So the now data scientists were using Anyscale workspaces. As part of that, they were also able to use VS Code. So previously, we had no separate productivity or an IDE for our data science team. Now we had VS Code, which was in two different ways that we could use. One was a browser version, one was a local version. So those were significant improvement in the new platform. Similarly, we had improved logging. So like I mentioned before, previously we had to log into CloudWatch or log into kubecluster to get the logs out. This time around, it was so much easier and simpler to just see the logs by logging into Anyscale workspaces or by going to Weights and Biases platform and looking at the logs right over there. Similarly, in another model migration, the next one, which is model B, we experienced the monthly scoring pipeline runtime being reduced from 2.5 hours to 16 minutes, which was a significant improvement. At the same time, what we experienced was reduced AWS instant costs. Because the training pipeline and the scoring pipeline were running for lesser time now, what it meant for us, we experienced 48% reduction in the use case, running the use case, training, and scoring pipelines. At the same time, we also added some cost control measure. So in Anyscale workspaces, you have a way in which you can set up the maximum number of workload which you can spin up as part of the cluster. Similarly, the third model that we migrated, we saw a massive reduction in the runtime for scoring pipeline from 9 hours to 1.5 hours. Similarly, we also experienced AWS cost and Anyscale cost, combined cost of the use case reduced by 52%. And in this model also, we had set some cost control measures. In the last section, what I want to do is just share one of a very specific use case and just demonstrate how we have used Ray Remote by just tweaking a few lines of code and parallelizing our code. So what you see on the screen is a code snippet. So this is a very standard function. For this use case, we were building a k-means model, and we were scoring over this k-means model. So we would get the project configs, we would download the model from Weights and Biases, we'll get the features from a feature store, and finally, we would call this k-means scoring function, which will input all this data in and then give the model output. The model output will be uploaded back to the database, as this was a batch service. So previously, we had this score function that would be called from the scoring pipeline. So how it would work with, in the first line, it would create the scoring data set. And in the second line, it would pass the entire scoring data set and call the k-means score upload function once. When we replaced this code and started using ray.remote, we made a very small change in this code. So what we did was we removed those 2 lines of code and replaced that with these 2 lines of code. So the changes were, we had a function called create chunk loader, which would just split the entire scoring data set into multiple chunks. So in this case, it was 14 chunks. And then instead of calling the function one time, we would call the function 14 times by going over all the chunks that were individually created. And we were using ray.get and remote function, and were passing these chunks instead of passing the entire data set. We also made one minor change, was we added this decorator ray.remote to the call function. So the next thing I want to show is how it looked like from the Grafana dashboard. So this is the Grafana dashboard screen snippet that comes out of the box with Anyscale. So what you see on the screen right now is the first 5 minutes of the running the code that I just showed. So as you can see on the screen, in the red, the number of tasks quickly gets spun up, and from 0 it goes to 14. So does the active number of tasks on the right side, which you see in green. After approximately 10 minutes of running the code, the screen would look like what you see at the bottom. So as the task would finish, you would see that tapering over time. So the task would finish, And eventually, around in 15 minutes, the whole pipeline would run. Another way to look at it is using array dashboard. So the first row that you see on the screen is the head node. And all the rows that you see at the bottom are those individual functions that were called, which are like separate tasks that are created by Ray parallelly to process all the data in the scoring pipeline. So let's have a look at the results now. So the scoring pipeline for use case A, without using Ray, took us 2.5 hours when it would ingest approximately 13.2 million rows. After making the code changes and implementing ray.remote, it took us around 16 minutes to ingest exactly the same amount of data with using Ray. So the efficiency improvement that we observed with this particular use case was over 90%, which is amazing. Finally, a few key takeaways. Anyscale has stabilized our platform. It has added numerous features for our data science team. Weights and biases has boosted our data science team's productivity to a large extent. And access to distributed computing has provided ability to service more complex requirements for us. So we are able to work on new use cases which were not possible before for us. So what's next for OneDigital machine learning platform? We want to continue using and exploring Ray-tuned library. What we want to do next is explore AutoML as part of the Ludwig integration that Anyscale provides. We also have Ray Serve integration in our roadmap. We explored a bit of the LLM technology that Anyscale provides. So we had a mini hackathon recently in the last 1 month in which we were able to test the stable diffusion model that Anyscale provides. So now we are looking forward to exploring Anyscale private endpoints and Anyscale fine-tuned API, which was released and announced earlier today. And lastly, we also want to explore model registry of weights and biases. So that's it. That's the end of my talk. Thank you. Yes.
Can you talk a little bit about? Oh, sorry. Can you talk a little bit more about weights and biases and I guess, just at a more conceptual level, like how it influences your ML pipeline and stuff like that, and how you guys tune things with it?
Yeah. So the question is to explain a little more about weights and biases on a conceptual level and how we have integrated and using it. So what we have seen is, since we have replaced MLflow with weights and biases, and the version of the MLflow that we were using were actually open source, so it had limited features. Now we see with weights and biases, it has really boosted our data science team's productivity. So at conceptual level, what we have done is we are using that in our pipeline for our model storage solution. So every training pipeline completes by pushing the trained model to weights and biases storage. It takes care of the versioning. It takes care of multiple models that we may want to deploy using the same use case. It also helps us to download the model with each scoring pipeline that starts. So that's how we have basically we've been using weights and biases. But at the same time, there are so many other features of weights and biases that we use. So there's a feature called weights and biases reports, which the data science team is now using to have better conversation with the stakeholders. So you can pull in all the metrics for a particular use case, whether it's in production or just an ad hoc experimentation. And then you can quickly create a report. And you can automatically push in all your metrics, charts that you have, and share that with your stakeholders. We are also using weights and biases model metrics throughout this training and scoring process. So weights and biases API are really intuitive and easy to use, and we write the code using those APIs. And the data scientists, they don't have to do a lot of work to make this work, all they have to do is use those API that quickly propagates all the values while running the model to weights and biases. It gets stored easily, and you can pull off that data anytime that you want for experiment tracking.
Hey, when you think of like Ray internally, and you think of the theme that Ray brings to the table, and when someone asks you internally, is it scale? Is it performance? Is it ease of use? Is it flexibility? Like, what's like the main theme? I know all of them kind of apply to your use case, but like, what's like the main thing that sticks out for like everyone internally, given your experience so far?
So the question is, in the Ray journey, what exactly is is it scale? Is it efficiency?
Yeah, I guess what stands out the most to like you and maybe the team? Is it the flexibility of Ray? Is it the scale? Is it the performance? Is it the cost savings of what Ray brings to the table? I'm just curious, like which one like is the most important to you?
What's the one thing? So for us, I would say if I had to choose one thing, it's actually enablement. So scale, yes, but we are not at that level of scale with the scale is the only problem that we have got, but rather it's enablement. So when we started using Ray and Anyscale, we got access to a lot of things that our data scientists were never able to do, which just included all these features that come out of the box of Anyscale. So spinning up Jupyter Hub, using workspaces, creating production jobs easily. So all these numerous standard features of Anyscale and Ray. And yes, an extension to that would be distributed computing. So we never had access to a good distributed computing solution, which we now do because of Ray.remote. And then there's this whole suite of APIs that is under Ray Air, and we are really excited to use that in the future as well. Is that it? Thank you, everyone.